When an owl flies at night, your brain waits for a sound that never arrives. Not because the owl is small or careful, but because everything about its body suggests it should be loud. These wings are large. They move a heavy body through cold, dense air. By every rule of physics, they should announce themselves. And yet the owl passes through the darkness as if the air itself refuses to resist. This silence is not an accident, and it is not gentleness. It is the result of a design that solves a problem engineers still struggle with: how to move through air without creating noise. Unlike most birds, an owl's feathers do not end in clean, sharp lines. They dissolve into fine, comb-like edges that break turbulent air into smaller, softer movements. Instead of allowing vortices to grow and collide, the wing dismantles them before sound can form. Along the trailing edge, the feathers behave less like surfaces and more like fabric, absorbing what remains of the disturbance, scattering it into nothingness. Air is no longer struck or pushed aside. It is guided, fragmented, and quietly released. Nothing about this flight is weak. The owl moves with power, control, and speed. The silence does not come from caution, it comes from mastery. No engine of comparable size can do this. Not without sacrificing efficiency. Not without adding complexity. Not without failing at scale. But evolution did not design for machines. It designed for survival. Long before the owl ever sees its prey, long before the hunt becomes visible, something more important has already happened. Sound has been removed from the world. And in that silence, the hunt has already begun.
In complete darkness, vision becomes unreliable. Edges disappear, shapes dissolve, and distance turns deceptive. But sound remains honest. For an owl, hearing is not a secondary sense. It is the primary way reality is measured. An owl does not simply hear that something moved. It knows where that movement exists in space, how far away it is, and whether it is rising or falling. All from a sound so faint most predators would miss it entirely. This precision begins with an imbalance. The owl's ears are not symmetrical. One sits slightly higher than the other, creating tiny differences in when sound arrives. Those delays are measured not in milliseconds, but in microseconds, enough to turn time itself into distance. The facial disc gathers sound the way a satellite dish gathers signals, subtly reshaping with every head movement to refine the incoming information. What looks like a face is, in reality, a living acoustic instrument. But this system only works under one condition. The owl must not hear itself. Every unnecessary sound would mask the signal, blur the spatial map, and introduce uncertainty at the moment precision matters most. This is why silence is not a separate adaptation. It is the foundation that protects the owl's hearing from interference. When prey moves, the owl does not react emotionally or impulsively. Its head turns first, slow, deliberate, exact. The brain locks coordinates before the wings ever adjust. Flight becomes a correction, not a search. The strike is not a guess. It is the final step of a calculation already complete. By the time the owl descends, the outcome is no longer uncertain. The prey is not surprised because it was slow. It is surprised because it was already mapped. This is not hunting driven by instinct alone. It is perception refined into certainty. The owl is not silent to remain unseen. It is silent so that the world can be heard with absolute clarity.